Okay, this question is on the Princeton Review, page 99, number 21, okay? Now, they ask you to find the limits. X on this edge. I just put the question here easier for you. So edge, you approach to 0. And the function is 3 plus h squared minus 9 over h, right? You see, when you have this one, generally we say just put the h value for the edge here, right? Get it? But there's a problem. When you put the h at the bottom, that will be what? 0. And when you put the h on the top, you have 3 plus 0, oops, what's wrong? Squared, right? Minus 9, like this. So when you have that, will be 9 minus 9, 0 over 0. In calculus, this one we call it as what? We call it as indefinite or indeterminate. Okay? Indeterminate means what? We don't know. 0 over 0 may be huge, may be constant, may be 0. We don't know. Depends on the top and the bottom approach to 0, how fast they approach to 0. If top approaches 0 way faster than the denominator, that's the infinitive. Oh no, that's a 0. But if the denominator approach to the faster pace to the 0, the overall is what? Infinitive. And if they have same pace approach to 0, that's a constant. Okay? So it depends. So right now, you cannot do this one directly. So what are we going to do? We do what? Algebra simplification. You see here? When we start the question, immediately go to what? Algebra. Pre-calculus stuff there. Now, let's break this one down first. What's that? 3 squared plus 2 times by 3 times h plus h squared. Okay, that's the formula. But for you, Amanda, do you know this formula? Algebra formula?
Yeah.
This is called what? Like this one here? A plus b squared. So you see, our lessons, the ways like this. When I'm teaching this part, you will see something basic things. I try to extend it, represent it to you, so you can recall on this, okay? This one will be what? A squared plus 2ab and a plus b squared. That's the formula we're using right now. 3 squared is just a squared plus 2 twice the ab, so twice the 3 times h. And the plus h squared. And then we're minus 9 over h. See that? Of course, you may say, I'm sorry. Yeah, you may say, hey, I forgot this one, right? I forgot this formula. But you still can get it. 3 plus h squared means time together, right? 3 plus h. You can use the FOIL. 9. Get it? This time this one, 3h. 3h together is 6h here. And then this time this one, h squared. No problem? That's the last result. That's in case you couldn't get it, right? So 9 and 9 cancel. So you have what? We can take the h out. You have a 6 plus h over h. What happens? What's the next one you're going to do? That's the purpose. That's why we're doing this way. So you go what? Limits. You cancel. Get it? So that will be what? Edge approach 0. 0 here. This is 0, so no more, right? Just 6. You see that? What does this mean? This means numerator approaches 0, denominator approaches 0 at the same pace. So end up with what? A constant. So that's why sometimes this is called, we call it as a indeterminate, because we cannot determine. Depends on how to work there. Okay? Any questions so far? Dominic? Good. You're good? Want to understand? Okay, what's the other one? Okay, if you have no question, I'm asking you both, all of you do number 22. If h is a variable, so this is 22 now. I put a question here. Limits x approach, no. Just be careful. Even though we were so used to h is the x is a variable, right? But for this case, h is a variable, approach to 0. And we have 1 over x plus h, right? And minus 1 over x over h, right? Now, when we do this one, of course, we need to build up, when we do the subtraction of the two different denominator, right? What are you gonna do? Time by x here, time by x here. Change the LCD. This one is x plus h. This one x plus h. Get it? Now, when you do that, the top part you have what? X and x plus h, right? And then you have x minus, be careful, huh? The negative sign go to here and here, okay? So minus x minus what? H, no problem? And then the bottom one is over 1 like this. Division line, change to what? Change the multiplication. We never do division with fractions. Remember that? Okay, if that's the case, so we will have what? Time by what? 1 over h. No problem? Times reciprocal. So after we got that, you see here, this cancel. And then after cancel this one cancel with this one. So you got negative 1 over, oh, this one limits, huh? H approaches 0, right? H no more. This h cancels this h. So you have what? X squared. Got it? Dominic, you got it correct. Huh? What? Understand? Huh? Right? Let me see, this boy got it correct also? I couldn't see the page, okay. So let's look at number 20. Can you please do 20? For number 20 is this. Limit x approach to 0. Sine x over x equals 1. This is the key part. Okay? That's what we're going to use. So we have number 20 here. The question is limits, right? X approach to 0. Sine square 7x over sine square 11x, like this. So what you can do is this. You change it to sine 7x, you divide it by 7x, and time by 7x, like this. Of course, this one is going to be squared. Huh? All of them is under squared right now. And then this sine 11x, and I need, because I put square outside right now, see that? So this one divided by 11x and times by 11x. You see, here the 7x, just like the position of the x. Here, the 7x here is just like this x there, get it? So this part will be what? 1, get it? And similar for this part, also is 1, get it? Of course, we got to put the limits here, okay? H opposed to 0, like this. And then we have limits, x approaches 0. We have what? 7x over 11x squared. And then by that way, x cancel. Huh? So we have only 7 over 11 squared, which is 49 over 121. Is that clear? Right? So this is the key. Now, this one, as Amanda asking is what? Right? Tangent 7x, right? Equals what? Sine 7x over cosine 7 of x. And then over sine 5x, right? Get it? Now this is over 1. See that? So we can simplify further. Sine 7x over cosine 7x times by 1 over sine 5x. Get it? And then we can put this one together. Of course, you still keep limits there, okay? Yeah. So we can get what? This two together, that's from what we just did, right? That's 7, 11, so this one should be 7 over 5. No problem. This one 7 over 5 already. Can you follow me, Dominic? And then this now. You have limits 1 over cosine 7x. X approach to 0. Right? So x approach 0, this is what? Equals what? Amanda? This one equals what? Cosine 0 equals what?
No, 1.
Yeah, and the 1 over 1 is 1, so 7 over 5. Get it? No problem, huh? And I noticed that everyone, you look at numbers, do number 6, because I noticed that we need to work on this. The key part here is this. Factor the bottom one, denominator. What do you got? For your x times x, x squared. 12, you have 1 times 12, 2 times by 6, 3 times 4. Which one you want to choose? Zoe? 2 and 6. Okay, 2 and 6 is a good one. Which one should be negative? Because one of the number 2 or 6 should be negative. Which one? Negative 6? Because when you cross multiply, right? Negative, see here? X times x, x squared. 2 times negative 6, negative 12, match. The third one now, cross multiply. Negative 6x plus 2x, right? Equals negative 4x, match exactly here. So that means the bottom one you can factor as what? X plus 2x minus 6, right? Oh my goodness. This one still, even though this one cancel, right? Huh? Still, denominator equals 0, right? Now, let me ask you, Dominic, what's the answer should be? Huh? Yeah, not exist, you can say 1 over this is the x minus 6, right? Is that positive or negative? Why positive? This is 6, right? They said x approaches 6 from the right side. Means like a 6.1, 6.001, like that, right? Always bigger than 6, but very, very close to 6. So even though this one is 0, but what? Still positive. See that? That's why the answer should be what? Positive infinity. Okay? That's it. Otherwise, without the factoring here, you don't know if it's a positive infinitive or negative infinitive. That's why generally for this kind of rational expression, when you find the limit, both numerator and denominator factoring as much as you can, and to see some common ones and get rid of those. Okay. Okay. Now, absolute value sign. Anytime you meet that one, you get deleted. What's the definition for absolute value sign? Actually, we're reviewing for algebra. You see, most of the time we're reviewing on algebra. It's a good opportunity you catch it up on algebra. Huh? Now, 1x here, for example, this is 0. If x on this side, for example, like a 2, right? That means 2 absolute value still 2, no problem? So that means whatever inside, put it outside without absolute value. That's the time it happens what? 1x greater than or equal to 0. Get it? How about this one? For example, this is negative 2. Absolute value of negative 2 equals what? And
negative 2.
Absolute value of negative 2 equals what? Armando?
2.
Zoe, do you agree? 2 or negative 2? Positive 2, because the result from absolute value always positive. But at this time, we want to use what's inside to represent. Dominic, can you show without use negative 2 as the answer? What are you going to do? Do you need to put a negative in front? Right? We know positive 2, but if you want to use the format of original one inside the absolute value sign, you have to put negative 2, no problem. So that's why when x less than 0, we put what? The answer is negative x. No problem? Understand? Okay, after we quickly review on the absolute value sign now, we can get what? Break this down now. This, be careful, this time x approach to 0 from right side. Is x positive or negative? Next?
Positive.
Positive. If it's positive, can we get rid of absolute value sign now? The top is x, right? The bottom is what? Follow this definition. Should be what? Armando.
X.
Just x, right? Because we knew x is positive. When we delete the absolute value sign, we have to do the x beside it. No problem? And then this to cancel. That's just a 1. You got it? Because I need you really like pick up the question. Because I just do number 10. The first step is what? Go ahead. Okay, after you factor the bottom, what do you got? Huh? X plus 7, x minus 7. Dominic, did you do this way or we just plug in 7 inside? You see that? Okay, that's good. Okay, now, after you got that, what's the next step you're going to do? X approaches 7. So the top part can be 7, right? The bottom one can be 7 plus 7, that's no problem. But the problem from here, this one, x minus 7 will be what? But x approaches 7, is here? X approaches 7 from the right side, right? You got it? From the right side, right? So that means the number, just imagine just like a 0.7, 0.00001, like that, right? So this part should be what? This number minus 7 should be what, Anna? What? 0.001, like this, huh? Of course, it's a close 0. So whatever time k is 0. But this actually is a 0 on the right side. Get it? So the answer should be 7 divided by a very, very small number, but positive, equal to what? Amanda.
Positive infinity.
Good. Very good. All right. Now, I just randomly pick up something. 18 and 19. Both of you do it. For sine, right? How the graph sine looks like? See, everything which we're talking about the calculus, right? But everything related to what? But this is trig, algebra, right? Here, when x approaches infinity means what? This function will be either equals 1 somewhere here, or -1 somewhere here, and a 1 again, -1 here, or in between. Keeps shaking. What does that mean, Zoe? Not exist. That's good. Not exist. Right? Okay, let's try to number 19 now here. Well, that one should be, and you see, they said x approach was infinity, right? 1 divided infinity equals what? 1 over infinity. 1 divided by a huge number should be 1 divided by a huge number. For example, 1 divided by huge number. What happened? Close to what? 0. Sine 0 equals what? 0. That's the answer. Is that clear? If you want to check if this piecewise function continues at x equals what? 3, right? At x equals 3 like this. So we got to check with what? X approach to 3 from left side, this function. And if equals limits x approach to 3 from the right side of the same function. And then check f3, right? Okay, now what's this? What's this one? -3. How do you find x approach to 3 from left side? Which part are you going to use? Anna, which part are you going to use?
X less than 3.
So this part, right? Okay, that's good. So use this now. So that means what? 4 times by just 3 squared minus 2 times by 3, right? So this is 6, 24. 24 minus is 18. Is that 18? No. This is 9. 9 times 4 is 36. So this is 30, right? How about here? Amanda, x approach to 3 from what? The right side.
30.
That's 30. So that means this two equal. If this two equal, what does that mean? Is the limits exist at x equals 3? Sorry? Limits exist if the left limit and right limit is equal, right? So limits is okay. Now let's check F3. F3 equals what? Which one are you going to use, Amanda?
10x minus 1.
So 10x, x is 3, minus 1 equals what? 29. This one equal? Not equal. If this not equal, what does that mean? Means limits exist and not equal to the value of the function. So this one is not continuous. You got it? All right. So now if you want to check if this function continuous or not, right? You need to what? You need to see where because this equals 1 over x, cosine x, right? So you need to look at the where of the x to make the cosine x equals what, Zoe? So they check continuous, right? Actually, we just find out where the discontinuity first. Where? So cosine, we're looking for what? Cosine x must be equals what? Dominic? 0. Where the cosine x equals 0, that's to make the function not continuous. So you exclude those x values, you can find out where the function continues, right? So if cosine x equals 0, x must be equals to what? To make this discontinue, to make this one equal 0. When cosine equals 0, we need to have x equals either pi over 2 or 3 over 2, and then keeps going. Okay? Right? How do you represent this one in general form? 2 pi n? Okay, look at here. If you plus 2 pi, okay, we got this one here. Plus 2 pi, right? Always, right? So you have a pi over 2 plus what? 2 pi is okay, right? But 1 2 pi, 2 2 pi, 3 2 pi, so that's 2 pi n, that's fine. But n is what? Integer, right? And the other one is what? 3 pi over 2 plus 2 pi n. Get it? So the n is still integer, right? So that's the way you can find the what. But they ask you, is the function continuous on all, everywhere? The answer is no. Only on the x value which is not equals to this. Get it? Now, is the function, look at number 4, is the function fx equals secant continuous on the interval of this? Yes or no? Because we know pi over 2 is not good. Also, negative pi over 2 is not good. So the boundary is not included. But how about we say negative pi over 2, pi over 2 like this? Dominic, is this good? Is the second function continue doing this stuff? Which one?